Theia was this planetary body that was roughly the size of Mars. And through this collision, a lot of particles were ejected, probably completely destroyed. We don't really know how much of Theia was preserved.
Earth is rocked off its axis. Its surface liquefied. Chunks of Earth's mantle are shoved into space. As a planetary body, Theia ceases to exist. Its remains are absorbed by the Earth and intermingled with the debris field. A new planetary body is formed, the Moon. Further evidence is found in rock samples from the Apollo moon landings.
This is a sample from the moon, if you can see it. This was collected by the Apollo 15 mission.
Moon rocks contain isotopes identical to those found on Earth. When the moon arose, it is first covered with a magma ocean.
People imagine the lunar magma ocean to be like this magmatic chamber I am describing, but at the surface and covering a whole planet. I see it as this ocean, like the Pacific, but this has to be like completely magmatic, orange, and like probably like fluxing around and probably moving.
Conditions in the lunar magma are as hellish as we can imagine. But a microscopic treasure forms in the magma: crystal zircons. These are the same gemstones used in jewelry, but the zircons in the Apollo moon rocks yield a different treasure.
So those zircon are very important because we know they crystallize in this lunar magma ocean. We know roughly when they crystallize in the lunar magma ocean. So they are one of these old pieces of the moon that we are looking for, one of these old pieces that we can use to date the origin of the moon.
Zircons not only give the age of the moon, they set a specific date for the collision.
The age of the moon is 4.51 billion years old.
4.51 billion years ago, Theia becomes part of Earth and forms the moon. But the story is not over. Space probes measure the moon slipping 3.8 centimeters further away each year. One day, the moon will break free. When that day comes, there will be no more tides, no more romantic moonlit nights. Could planetary orbits be inherently unstable? Could the chaos of planetary migration return? Haute-Provence Observatory, France. It's here that a discovery from a faraway star gives one of the biggest revelations about our own solar system. The story begins when Swiss astronomers Didier Queloz and Michel Mayor noticed something unusual about a star 50 light-years away in the constellation of Pegasus. Everything about this star is ordinary. A main sequence midlife yellow dwarf, just like our sun. But with one strange difference. The star at Pegasus 51 is rocking back and forth. It's a weird anomaly astronomers have never seen before. They check their instruments. Everything is working, including their new spectrograph, a device that splits the starlight from Pegasus into rainbow colors. Hidden inside the colors are patterns of lines. By tracking the day-to-day movement of these lines, astronomers make a startling discovery. Pegasus 51 has a planet. But no one has ever seen a world like this. It's half the mass of Jupiter, yet it's extremely close to its star. 9 times closer than Mercury is to the Sun. The planet at 51 Pegasus must be inside the corona, broiling in temperatures over 1,000,000 degrees Fahrenheit. Soon, another star, and then another, and another. Astronomers have now confirmed over 3,700 exoplanets beyond our solar system. Nearly all of them are Jupiter-class planets, grazing their host star. They're a new, previously unknown type, called hot Jupiters. They're so numerous, hot Jupiters challenge theories about the origins of planetary systems.
It's very difficult to make a planet close to the star because there isn't enough mass to build a giant planet very close to the star, and there's gravitational frustrations for trying to build a planet very close to the star.
Astronomy is shaken with a new revelation. Planets do not stay put where they're born. When they're big enough, they migrate. It's a process called planetary migration. And yet, our own solar system has no hot Jupiter. Astronomers realize the Jupiter in our solar system was once on the move as well, but its migration was halted by a resonance with Saturn. Pegasus 51 shows where a planet lands when its migration is not blocked. The strongest evidence for the Grand Tack hypothesis comes not from our solar system, but from exoworlds charted around other stars.
Planetary migration is a universal concept. We see it, evidence of it, out there in extrasolar planets, other solar systems. There's no reason why planet migration shouldn't have operated in our own solar system.
The New Horizons probe finds evidence for roving planets within our solar system. While charting ancient craters on Pluto and on the surfaces of its moons, the science team discovered many craters are the same age. This suggests that they were formed by a single event. Even way out here, tiny Pluto was smashed by a wandering planet. The Pluto catastrophe may be related to other planetary migrations in the outer solar system.
It was noticed that the exact orbits of the giant planets, particularly the outer giant planets, the icy planets, Uranus and Neptune, can be explained by their migration outward. There's a point in time about 3.8 billion years ago where Uranus and Neptune trade. And it's because of what some of these mean motion resonance interactions that we were talking about earlier. So this mean motion resonance involving Jupiter and Saturn and so forth just causes all heck to break out in the solar system. Uranus and Neptune, all of a sudden, in 3.8 billion years, they literally swap places, and all that debris in the outer solar system gets flung inward towards the inner solar system.
The disruption in the outer solar system causes a new wave of violence. Astronomers call this epoch the Late Heavy Bombardment. It may be possible that swapping orbits with Uranus is how Neptune got its moon. Today, the epoch of planetary migration appears to be over. The solar system seems stable, but what does the future hold? Computer simulations reveal what may be the greatest threat to the solar system in over 4 billion years. It comes from a very special relationship between Jupiter and Mercury. Mercury's orbit is slowly perturbed, thanks to a subtle but constant gravitational nudge from Jupiter. A new resonance, like the one between Saturn and Jupiter, that saved the inner solar system, is forming between Jupiter and Mercury. In 2001, computer models for the solar system were run 2,500 times.
They plug in the positions and the orbits of all the planets in the solar system in a computer, and they just let it run through time, through millions of years, hundreds of millions of years, billions of years, to find out whether or not these orbits are stable.
Change the location of one planet, say Mercury, by 1 millimeter, and you find that that change will give completely different predictions about where everything is going to be millions of years in the future.
To see how quickly and easily things can change, we have only to go back to our metronomes.
All I have to do is stop this platform from moving so that it cannot swing freely. Now, there's no way for the metronomes to influence each other. They're good metronomes, but they're not perfect. They can't be going at exactly the same frequency in the same phase, and they're just going to fall apart because they have no way of forcing the others to go to resonance.
The same applies to planets. Any small change can disrupt their harmony or restore it.
Now that the platform is free to swing again, it can again transfer energy and sync them up just like we saw the first time.
Scientists want to understand the consequences of a destabilized planet Mercury. In one case, Mercury leaves the solar system. The loss of its gravitational pull disrupts the balance of both Venus and the Earth. Earth and Venus swap orbits. The superheated atmosphere of Venus cools. Massive rains pour onto the face of the desert planet. Oceans arise. The land cools. And the air thins. Even the remains of an ancient visitor begin to cool off. Venus becomes like Earth. But the reverse happens to the Earth. As Earth settles into Venus's orbit, temperatures rise. The air becomes unbreathable. Glaciers melt. Oceans boil. The sun looms larger in the sky, only to be obscured by a thickening cloud cover. Suffering will be great, but brief. The entire 4 billion year pageant of life is cooked in a matter of days.
Complete and utter destruction and elimination of the Earth. I'm not just talking about higher life, I'm not just talking about civilization, but everything, a sterilization of the planet, is something that I would want to think about a bit.
Sterilized, uninhabitable, and quiet. There is another possibility, equally dark and apocalyptic. A runaway Mercury is deflected by the gravity of Venus and barrels toward the Earth. It may be a frightening encore to the opening act of our solar system.